Hey everyone, and welcome. Today, we're digging into a massive, kind of invisible problem that silently bleeds millions from industries and energy, maintenance, and even water. We're talking about mineral scale, and it's literally clogging the arteries of our industrial systems. But what if the solution wasn't more chemicals, but pure physics?
Just look at this. This slide puts the hidden enemy right in your face. On top, you've got the industrial version of a clogged artery, a pipe just choked with mineral scale, and below it, a clean, efficient one. That buildup you see, it acts like an insulator, forcing the whole system to burn more fuel and wear itself out just to keep up. This is the exact problem we're going to solve today.
And the cost of this is, well, it's staggering. We're talking about a layer of scale that's only 1 to 3 millimeters thick. That's about the thickness of a credit card, and it can slash your heat transfer efficiency by up to 40%. Now just imagine that waste, adding up every single hour, every single day your plant is running.
So here's our game plan. First, we're going to define this hidden tax on your efficiency. Then we'll look at why the old chemical solutions just aren't cutting it anymore. After that, we'll dive into the cool science of a new approach, see it in action with a real-world plant transformation, understand the total business impact, and then, my favorite part, show you how to find this potential in your own facility.
Okay, let's jump right into our first section. We're calling this a hidden tax for a reason. It's this constant, silent drain on your resources that just eats away at the bottom line, often completely unchecked.
So what exactly is this stuff? Well, think about it like this. All industrial water has minerals dissolved in it, right? When you heat that water or put it under pressure, those minerals basically fall out of the solution and bake themselves onto any hot surface they can find. They form this hard, insulating crust, and that crust forces your pumps, your chillers, your compressors to fight against themselves, burning way more energy and just shortening the lifespan of your most critical equipment. Let's put some hard numbers on that damage. You can see it right here on the chart. That tiny 1 to 3 millimeter layer causes a massive 10 to 40% efficiency drop. And the bottom line? A scaled-up system can gobble up 30% more energy just to do the exact same job. That's just pure, preventable waste. Now, for decades, the go-to answer has always been the same. Just dump more chemicals into the water. But honestly, that approach is like running on a treadmill. It's a constant, expensive effort that's just loaded with its own set of problems and risks. And this slide, it just perfectly breaks down that flawed cycle. You are completely dependent on constant chemical dosing. If you miss one, scale immediately starts to form. There's always the risk of human error, and if you overdose, you're not just wasting money. You can actually start corroding your equipment. It's a system that creates sludge, never-ending operating costs, and a pretty significant environmental headache. It's a game you just can't win.
So, if chemicals are part of the problem, what's the solution? Well, it's a total shift in thinking. It's moving from chemistry to physics. It's an engineering-first approach that doesn't add a single thing to the water, but instead changes how the water itself behaves.
And this is AE Flux. This is the technology at the very heart of this physics-based solution. It's an inline device that's 100% chemical-free. It uses zero electrical power, and it's totally maintenance-free. It's just a simple, elegant piece of engineering that's designed to be a permanent solution, not another temporary patch.
The technology itself is called physical water conditioning. And here is the absolute key insight. It doesn't remove the minerals. Nope. Instead, it uses a very precise physical field to change how they crystallize. The whole focus is on changing the shape and behavior, the morphology of the minerals, while leaving the water's chemistry completely untouched.
This slide shows you that science in action. It's amazing. On the left, you have calcite. That's the villain of our story. These are hard, spiky crystals that are basically designed by nature to stick to surfaces. But on the right, you have aragonite. AE Flux changes the physics of the water to make these soft, harmless little microcrystals that don't stick to anything. They just flow right on through the system.
So how does it pull this off? It's really a four-step process. First, the device charges the pipe itself, creating that precise physical field. Second, as water flows through, that field influences how the mineral ions collide and interact. Third, this influence causes that critical shift, from the sticky calcite to the harmless aragonite. And finally, these new little microcrystals actually help dissolve existing scale, and then the whole shebang just gets flushed right out of the system.
So that all sounds great, right? But does this elegant science actually deliver in a messy, real-world industrial plant? Let's look at the proof.
We're going to walk through a complete 4-phase case study of a plant that was totally transformed by this.
So our subject is this industrial facility that was dealing with very, very hard water. They were facing rapid equipment fouling, which was jacking up their compressor loads and just degrading their entire system. We're talking a huge chiller, a heat exchanger, and over 2 kilometers of pipeline.
Okay, phase 1 was descaling, and this is just incredible. Look at the before and after of their plate heat exchanger. That thick, caked-on, old-school scale was completely dissolved in just 6 weeks. And the best part? This happened while the system was running. 0 shutdowns, 0 chemical cleaning, 0 interruption to their production.
So with all that scale gone, what happened to their efficiency? Well, in Phase 2, they tracked the chiller's performance. They saw the condenser approach temperature, which is basically a measure of how hard the chiller has to work, improve by a full 2.5 degrees Celsius in just 8 weeks. This brought their system right back to its original, as-new design performance.
And what does that 2.5-degree improvement actually mean for the bottom line? It translated into a staggering 280,000 kilowatt-hours in recovered energy per year. That is a massive direct cost saving that was reclaimed simply by getting rid of that insulating layer of scale.
But the benefits didn't even stop at the chiller. In Phase 3, they looked at the plant's huge pipeline network. As the system cleaned the pipes from the inside out, their flow improved by 22%. And that, in turn, led to a roughly 15% reduction in the energy they needed just to pump water around the plant.
And finally, Phase 4, the environmental impact. Because the system could now handle higher mineral concentrations without scaling up, the plant could dramatically reduce its water blowdown. That's the process of draining water to control mineral buildup. So less water wasted, and of course, 0 chemical discharge into the environment.
Okay, let's zoom out for a second and connect all of these individual engineering wins into one unified business case. Because this isn't just about getting clean pipes. It's about a fundamental upgrade in how the entire business operates.
You know, the value here really rests on 3 pillars. First, there's the financial. You swap a never-ending operational expense on chemicals for a one-time capital investment that also slashes your energy bills. Second, operational. You protect your most expensive assets from corrosion, and you kill the risk of costly downtime. And third, sustainability. You make huge gains in water conservation and environmental compliance. It's a win-win-win.
So, you've seen the proof, but what could this mean for your facility? Well, using the descaling and efficiency assessment calculator you see here, you can actually plug in your own system's numbers, like your flow rate and operating hours, to get an instant estimate of your potential energy savings and your payback period.
Which really leaves us with one final, very important question. After seeing the physics and all the proof, you really have to ask yourself, what is the recovery potential that's currently hidden inside your plant, just waiting to be reclaimed? Thanks for tuning in.